Good morning, students. Today, the first topic that we are learning is how the lens brings about changes. So, whenever we are viewing nearby objects and when we are viewing distant objects. So, how does a lens change its shape or the curvature while we are seeing nearby and the distant objects is the first topic that we are going to study. Later on, we will even study the various disorders that are associated with vision. So let us start with the change in the shape of the lens while seeing distant and nearby objects. Now these are the two eyeballs which have been shown here, A and B. And the first figure here tells us about the shape of the lens when we are viewing distant object. Whereas the figure B tells us about the change in the shape of the lens when we are viewing nearby object. So here if we observe that whenever we are viewing distant object, light coming from a distant object. So when light is coming from a distant object, we know that it is always parallel. So we have shown two parallel rays of light or incident light has been shown. After the rays of light fall onto the lens, they will converge because it's a biconvex lens. So they will converge and we find that the rays meet at the retina, or we can say that the second focus lies on the retina, that is F2 will lie on the retina and we can see the distant object clearly. So if you see the shape of the lens in this case, we find that the lens has become very thin and the focal length when we see any distant object becomes maximum. So the focal length of the lens will increase. The second focus will lie on the retina and we can see the distant object clearly. So this is the shape of the lens, that it has become thin so that the focal length can increase. So this is what is the change in the lens that is brought about when we are seeing distant object. Secondly, light coming from a nearby object. When you are viewing any object which is close to you, in that case what happens is that the shape of the lens, again you can see it has changed over here. You find that the curvature has increased, or we can say the lens bulges out. And due to the bulging out of the lens, we find that the focal length decreases. So this is what is the change in the shape of the lens that is brought about when we are seeing nearby object. So focal length decreases and we can see the nearby objects clearly. So the lens becomes rounded or bulged out, or we can say that the curvature of the lens increases. So it curves out or it bulges out. And we find that the focal length decreases. Again, you can see that the second focus F2 is on the retina and the image is formed on the retina. So you can compare the lens in both the cases. While viewing distant object, the lens is thin, focal length is maximum. Whereas when you are viewing nearby object, the lens becomes rounded, focal length decreases and the nearby object can be seen clearly. So this is what are the two figures that are indicating over here. Let us now look at these important points. Near point of the eye, 25 centimeters. So near point refers to the nearest point or the minimum distance at which you are holding an object and you can see it clearly. Try to read the textbook by bringing it very, very close to your eyes. What will happen? Will you be able to read it? No, because there has to be a certain minimum distance at which you need to hold the book so that you can read the letters clearly. So what is that minimum distance at which we should hold the object in order to see it clearly? It is 25 centimeters. So the near point of the eye is at 25 centimeters, which indicates that only if the object is at a minimum distance of 25 centimeters, we can see it clearly. So this is also called as a near point of the eye, or a near point visibility of the eye, which is at 25 centimeters. Farthest distance of distinct vision, far point of the eye at infinity. Similarly, the farthest object which can be seen clearly without any strain on the eyes. Here also there shouldn't be any strain on the eyes. So the farthest object that can be seen clearly without any strain on the eyes will be at infinity for a normal vision. Means the farthest point from the eye that can be seen clearly is called as far point range of visibility, and it is going to be at infinity for a normal eye. So we have studied two things, near point and far point. Near point, that is the minimum distance at which a object needs to be held so that it can be seen clearly without the strain on the eyes, and that is 25 centimeters for normal eyes. Whereas the farthest point which can be seen clearly by the eyes without any strain is going to be at infinity for normal eyes. The capacity of the eye lens to change the focal length as per need is called power of accommodation. This is very important term, and it is often asked in the exam for 1 mark, and if 2 marks, then you need to even explain it in detail. So the capacity of the eye lens to change the focal length. So we have seen that the eye lens brings about change in the focal length when you are viewing distant objects and nearby objects. So accordingly, you can see any object which is at infinity and a minimum distance of 25 centimeters. So that is brought about by the lens by changing its focal length. So this capacity of the eye lens to change the focal length is referred to as the power of accommodation. In relaxed state, the focal length of healthy eyes is 2 centimeters. And the other focus here refers to F2, and that lies on the retina. So that we have already seen, that is here this point where the rays are converging is the point where you have the second focus which lies on the retina. So I hope you have understood this part, that is the change in the shape of the lens while seeing distant and nearby objects.